Hello everybody, my name is James Martin from QSC UK. I should be appearing on your screens now. Hi everyone, hope we're all doing very well. I'm here with my good friend and colleague James Bean. James, do you want to say hi?
Hi everyone.
Hi everyone. So as you guys all know, we're going to be talking about networking with Q-SYS today. Now this is not just going to be about Q-SYS. This is really going to be about all sorts of different AV networking protocols and how we can make them all play nicely together on a network. So we've got loads to talk about there. Just a little word of webinar housekeeping before we kick off. Feel free to ask any questions you like. The more questions, the better. But pop them in the Q&A section in Zoom. Don't put them in the chat. Obviously, you can use the chat for chatting. But yeah, put all your questions in the Q&A and then we'll read them out on the air and answer those for you there. Okay, so without further ado, I think we should get started. Now, with QSC, we've obviously been doing AV networking for a really long time. When Q-SYS first came out, it was like 2009, 2008. QLAN was very similar to what it is doing now in terms of the fundamentals of how that works. So we've obviously got a lot of experience helping integrators, helping end users with their networks, and we've put together a load of resources for you online to help with that. And as we've been helping people with their networks, we've categorized AV networks into three, broadly into three categories. So obviously there's all sorts of different networks out there, so this won't apply to everybody. But essentially we say you've got the plug and play AV network setup. So this might be where you're just installing a very simple AV system. You might just get a unmanaged switch and put a few bits of microphones, DSP, that sort of thing on there, and it's all going to work. And that might be your smaller integrator who's not going to do loads of network configuration. So that's one type of network. Then we've got our larger installations, or maybe we're using an enterprise network. So there we might be installing AV onto existing infrastructure. We're going to have to work pretty closely with perhaps the end user's IT team, make sure they know all of the requirements of using Q-SYS or using some other AV protocol on their network. And then we've got just manual switch configuration, where you're installing your own AV network and maybe you're going to configure that all yourself, build your own network, and you're pretty experienced in configuring switches. Now, for the first type, plug and play setup, we actually have a solution there. If you don't want to be configuring networks yourself, we have our own line of switches, which is the Q-SYS NS range of switches. It's Dell Enterprise Switch hardware, but running our own custom configuration, so you don't have to configure anything. But that's not what we're going to be doing today. We're not going to be talking about switches that already do it all for you. We're going to be talking about when you do want to configure your own network, what do you need to do, okay? Now, for people who are doing manual switch configuration, just so you know, on our website, if you just Google QSC network solutions, or you can find it through our website, of course, you're going to get taken to a page where there's lots of network resources there. There are some guides for switches we have tested, and there's also a list of switches that we know have issues or have problems, so ones to avoid, and just some general networking resources there. So that's really good if you're building your own network, or if you're working with a third party, with an end user, to make them configure their network. And then also, this is quite new. We've always had the online help for Q-SYS, the qsyshelp.qsc.com, but we've added a new networking section. So in there, we've actually got very detailed breakdown of Q-SYS networking protocols and all the different ports and the different requirements that different protocols have. So make sure you take a look at that as well. Feel free to copy this link right now, and if you want to have this open at the same time, you can have a look at those resources while we're doing the webinar if you want. Now, to understand AV networking, we've really got to understand what protocols like Dante, QLAN, network video, what are these actually doing? Because you might have an issue with audio dropouts, you might have an issue with device discovery. And if we don't know how those things actually work, then we can't really fix the problem. We can't reconfigure the network to get around that problem if we don't understand what part of the protocol is affected. So we're going to start off by taking a look at what is QLAN, okay? Now, the nice thing is QLAN is based off of totally standard IEEE network protocols. So we've not built it on some weird proprietary networking, which is why it can run on any gigabit switch, essentially. Now, let's have a look over here at the kind of things that you're likely to come across when dealing with QLAN. Firstly, we've got control and audio. And when I'm talking about control here, I'm not necessarily talking about third-party device control. I'm talking about the Q-SYS core and the Q-SYS peripherals interacting, sharing information, that native Q-SYS control. And for this, we're using TCP and UDP. Now, let's have a quick reminder about what the difference is between TCP and UDP. UDP is a very, very straightforward method of basic network communication. Now, when you're sending a UDP message, essentially what's happening is the sender just says, I'm sending you a message, and starts sending the packets. It doesn't really know if the packets have got to the other end. And if they don't, it doesn't really stop or anything. It just keeps going, keeps sending those packets. Now, that's really good for something like audio, because with audio, you know, we just want to be sending those packets really fast. They go thousands of packets per second. If we drop one, we don't want to stop everything and then say, oh, where's that packet gone? Let's find it and send it again. Because by the time we've stopped, we've introduced latency and other kind of problems. So audio in Q-SYS is UDP, where it's just sent all the time, very, very quickly. And if there's any packets dropped, we just carry on. Now, that's not so good for control messages. So with control messages, if one of them doesn't get to the other end, we need to make sure we find it and send it again, because that could be something really important. We might be turning off a mute or something. And if we send that control to turn off the mute, then, and it didn't work, and we think it did work, then all kinds of weird problems are going to happen, okay? So we use TCP for that, and TCP is great anytime you need a guaranteed message being sent. So for example, if we're telling a IO8 Flex to turn on phantom power, our PC is going to send a message to the core is going to send a message to the IO8 Flex. And that's going to be more like this. So the PC is going to say, I'm sending you a packet, and it's going to send the packet, and then the core will say, I got it, send the next one. Okay, we'll send the next one, send the next one. And it just keeps going back and forth like that. And if we drop one, we'll send it again. So that means control is guaranteed to work, but is a bit slower in networking terms. And audio is really, really fast. And if we drop packets, we just keep going. So that's control and audio streaming. Now, something else to point out about audio streaming is it happens very quickly. So we'll see later on, this is one of the protocols we're going to want to prioritize on our switch, because it's going to need to get from A to B in a very, very short amount of time. Now, we also have this third one here, PTP v2. Now, this stands for Precision Time Protocol version 2. And this is a protocol anyone can use, which is for clock synchronization. So in any audio system, we need to have our Q-SYS core, Q-SYS peripherals, third-party devices, anything that's doing audio and receiving that low latency audio, the clocks need to be synchronized in all those devices. And that means they're going to play the audio at the correct time, in sync, and then we have a great big networked real-time audio system. Now, this is also very time dependent. It needs to be delivered very quickly. It's also multicast, and we'll have a look at that later on as well. Then we have QDP. QDP is Q-SYS Discovery Protocol. So this is the protocol that sends out messages for all the devices to discover each other. This is going to be very important, because if we don't discover devices, we can't set up audio streams between them. So quite a lot here that is very important. Audio, obviously, but clock synchronization is needed before the audio can work, and QDP is needed to have all of these devices work together. So let's have a look at these in a little bit more detail. Now, QDP and Precision Time Protocol, these are multicast protocols. Now let's have a little reminder of what that means, okay? Here I have an example system where I have a transmitting device over there that is sending 3 messages. And it's sending the message hello world 3 times. Now, that's fine. It's going to 3 different devices, so it's sending it 3 times. But because it's actually sending the same message to multiple devices, it's not super efficient at this point here. It's using 3 times more data than maybe it needs to send to these 3 devices. Now, this is unicast transition, so point to point. Now, multicast is where we're going to send one message one time, but then it's going to be forwarded to all the devices that want to receive it, which is going to be these 3 here. So it goes to the switch, and then in the switch, it's going to fan out to lots of devices. And we'll see later on that multicast can cause some issues if we have lots of it and it's uncontrolled. So we'll get onto that a little bit later. But the reason we need to care about this is firstly, Q-SYS Discovery Protocol, QDP, this is multicast. So this is where, if you've used Q-SYS and you've opened up Q-SYS Configurator and you see the big list of Q-SYS devices on your network, then that is using QDP. So for example, the Q-SYS core or your PC running Q-SYS Designer is going to send out a multicast message that says, who's there? And then all of these other devices are going to reply with a response. They're going to say, I'm a USB bridge, and this is my name, and this is my IP address, and da, 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 da. All the information you see inside Q-SYS Configurator. And then the core uses that to set up communication with these devices. So this is very important. It is multicast. It's not very fast, though. It doesn't require super tight timing or anything like that. It's very low bandwidth, and it happens about once per second from each Q-SYS device. Now, the other multicast thing we need to know about is precision time protocol, where we are synchronizing all the clocks across our different audio devices. Now, this is UDP, this is multicast, and it happens a bit faster, and it requires it requires very, very fast timing across the network. So all of these packets need to be delivered in about 300 microseconds, which is a very short amount of time for the clock synchronization to work properly. So guys, just to summarize before we look at how we can configure all these things to work properly, typical things that cause issues are multicast not working properly and time-sensitive protocols not being delivered fast enough. So here, just so you know, Q-SYS Discovery, multicast, not time-sensitive. Control doesn't normally have any issues. It's not multicast, it's not time-sensitive. Now, clocking is both. So clocking requires both multicast and a fast network. QLAN audio just requires speed. And AES67, we'll have a look at that later. That is always multicast. The audio is multicast. And it's also time sensitive as well. So we're going to have a look at how we can plumb all of these things together, how we can get them all connected to play nicely together. Before we do, James Bean, can you have a little look? Is there any questions at this point?
Hello, mate. Yeah, we've got one just about deployment guides. Are we planning to provide deployment guides for Ubiquiti switches?
For Ubiquiti switches. I don't know that one off the top of my head. I can ask for you. I will have a look into that for you. Generally, what we're doing now is we're not providing as many guides for specific switches. What we're doing is providing you with general switch requirements, and then you can configure that on any switch. So you will find general switch requirements on our website, and if you know how to work with Ubiquiti, then you should be able to apply that to those switches. But I will have a look and ask if we're going to do any specific ones for Ubiquiti. All right.
Perfect. That's it for now, mate.
Cool. Okay. Well, let's have a look at, firstly, getting all of these time-sensitive protocols to be delivered fast enough. So we sometimes get questions about bandwidth at QSC, but it's not really about bandwidth. It's about speed, and they're not the same thing. Now, for audio and clocking, the time on the network must be about 300 microseconds or less. If not, the packets won't be valid by the time they get to their destination. They won't be useful, okay? And this is why, firstly, we specify that you need a gigabit network. Now, this isn't much of a problem anymore. People don't normally use a 100 megabit network, but this is the reason why. 100 megabit is 10 times less bandwidth, but it's also 10 times slower on the cable. So here on the cable, that's going to be about 120 microseconds. It's going to go through a switch, and then there's going to be another cable, and it's going to be another 120 microseconds. So that means one switch hop is 250 microseconds or thereabouts, which is dangerously close to 316. Whereas with a gigabit switch, it's 34 microseconds. So we can do quite a few switch hops and not have any problem. But the thing is, the switch is not just going to be forwarding these clock packets or just audio packets. It's forwarding all sorts of different things. And sometimes it's going to have to make a decision about what things go first. And the switch has no idea that the audio and clock are more important than other protocols in terms of getting delivered quickly. So that's why we're going to use quality of service, or QoS or QoS. People will refer to this in different ways, but it's called quality of service. And this is quite a simple thing we can do on our switch to tell the switch what packets are high priority, medium priority, low priority, and so on. And essentially, because the audio can't function properly without the clock synchronization, the clock must have the highest priority. So a Q-SYS clock or Dante clock, you know, whatever clocks you have, they should be the highest priority on the network. Now, the audio, once the clock is going, the audio can go, and that should have the second highest priority. And in Q-SYS, we have video as third highest priority, and everything else, no priority. There might be other things on your network that you also want to prioritize, and they can be below video. Okay. Now, how do we actually do this? Well, what we're going to use is these things, DSCP tags, or differential service code point, which nobody ever says because it takes too long. So like many things in networking, we're just going to use the acronym and say DSCP. So with DSCP, it's really simple. It's just a number from 0 to 63 that gets attached to a certain packet. Okay. For example, our clock packets have the number 46 assigned to them, and then we're going to tell the switch to prioritize 46. You're going to see them represented in lots of different ways, so it can be a bit confusing. Like here, this is a Wireshark capture. We're seeing CS7 and AF41. These are just different names for those numbers, but it's always really numbers from 0 to 63. Okay. Now let's have a look at a switch configuration and see how we can actually work with these. Like I said, essentially it's very straightforward. Whatever switch you're using, it should have a method for assigning a priority to a DSCP tag. Now this is a D-Link switch user interface. I'm sure others are very similar as well. Essentially what we've done here is, you see we have all the numbers 0 to 63. And what we're saying is clocking is highest priority. So 46, that is the Q-SYS DSCP tag for clocking, for PTP. And in the D-Link switch, 7 is the highest priority. So we've said 46, priority 7. Audio is tagged with 34. So audio is tagged with 34, and that is going to be the second priority. So that's priority 6. And then video is 26. And we're going to say that that is the third highest priority, which is priority, there it is, priority 5. Okay. And that's essentially going to mean that if there's ever a conflict when packets have to go over a link, the switch is always going to make sure that these packets get delivered first and then the other packets. Now, what about if we're using other AV protocols that also need quality of service? Is the quality of service requirement going to be the same for all of them? Because that would be really helpful, wouldn't it? Well, the answer is probably no. So for example, very common is that you're going to want to deploy ordinate Dante traffic and Q-SYS on the same network. And there's actually no problem doing that. We have a solution for this issue that I'm about to go into. But out of the box, there will be a bit of a conflict with the quality of service, okay? And this is why. So, like I said, remember guys, with Q-SYS, 46 clock, 34 audio. Now with Dante, it just happens to be different. So their audio is 46 and their clock is 56. Now, why is this a problem? Well, if we set up our switch for Q-SYS, we're saying that 46 is the highest priority. So now the switch thinks that Dante audio and Q-SYS clock are the same priority. And what you're going to see is that if you add more and more and more Dante, the more audio you add. Remember that there's thousands and thousands of times more audio packets than clock packets. So audio packets are like thousands every second, reasonably high bandwidth. At some point, there's going to be so much audio that it's going to get forwarded more likely than our clock is, because they're the same priority. And that might mean that the Q-SYS clock stops working properly, and then all your Q-SYS audio is going to stop. And we don't want that. So this is how we fix the problem. In Q-SYS Designer, you can go to File and Design Properties, and it's going to come up with this window here. Now, this window has this option that says QoS preset. So, like I said, by default, it's going to say QLAN. It's going to be 46 and 34. We're going to change that if we're using it with Dante as well. We're going to change that to this one, to ordinate. And then you can see that the clock is 56, the audio is 46, and then we can set up our switch for the ordinate quality of service. So we will tell our switch to prioritize 56, priority 1, and 46, priority 2. Q-SYS is then going to spit out those DSCP values, the same as Dante, and then Dante and Q-SYS will get put into the same queues, and everything will work just fine. So be aware that this exists. Don't worry about mixing Dante and Q-SYS together on a network, providing that you are doing quality of service in Dante mode and you have set up Q-SYS for ordinate quality of service. Now, there's also a third setting, which is manual, where you can actually set any DSCP tags you want. This is very rarely used. I wouldn't recommend using this unless you really have to. It's something which you might need to use if you have AES67 devices that are not following the specification and they have some weird non-standard DSCP tags that you need to line up with. But we find that that doesn't happen very often. And normally Q-SYS or Ordinate will solve your problems for you. So, James, are there any questions? Can you have a look for me?
No, I've just answered one, but just a quick one. When are we going to be making the recordings available on the website for the webinars? Do you know the date yet?
I don't know the date. We can share you the recordings if, like for example, if you're on this call and you want to get the recording, feel free to send me an email. You can send it to james.martin@qsc.com. We want to avoid sharing those with everybody because we'd much rather people came and joined the webinars and asked questions rather than just watching a video of it later on. But yeah, we can share those with you. Just drop me a line and we can sort that out.
Another question. If you use manual design properties, does that still support Ordinate?
Well, if you change it to something that isn't this, then no. So this is what Dante does. Dante tags clock with 56 and audio with 46. If you have manual, well, if you have manual and you set it up this way, then yeah, that's the same as the Ordinate preset. But if you change these to anything else, then it won't work with Dante in the right way. So for example, I've seen people change it to totally random numbers and then everything stops working. So don't do that.
Cool, perfect.
Cool. All right, thanks guys. Keep those questions coming. Now we also need to talk about clocking in the sense of how we can synchronize all of these devices, okay? We have something in PTPv2 called a clock domain. Now, it's a standard protocol that anybody can use, not just Q-SYS. Dante actually uses PTP version 1, which is similar but not compatible and it's different. But other devices will use PTPv2, for example, AES67, some digital signage devices, things like that. Now, we have this thing called PTP domain where we can set that to whatever we want. Now, by default, it's going to be set to 0. So it's just a number. And basically, if you have the same domain as another device, then you're going to synchronize in some way. Somebody's going to become the clock master, okay? Now, once once you're in the same domain, you can actually control who's going to be the clock master. So this is how it works in PTP-v2. This is how a clock master is elected, okay? Firstly, it looks at the priority 1 number of all of the devices in the network, and it's going to choose the one with the lowest. But what if they're all the same? So if they're all the same, guess what? It's going to look at priority 2 and pick the one with the lowest number. But if those are all the same, then it's pretty much random, because it's going to pick the one with the lowest value MAC address on that network interface, which could be anything, right? Now, most of the time, we don't really need to worry about this. Like, if we're just getting a load of Q-SYS devices out of their boxes, plugging them into a network, they are all going to have these settings by default, which means that whoever has the lowest value MAC address is going to become the clock master, and they're all going to be in domain 0. And that's probably fine, because we don't really care who the grand master is. It doesn't really matter unless we have a larger system with maybe a more complicated network, okay? But generally, we want to avoid the grandmaster ever changing, because every time a grandmaster changes, there's going to be an audio dropout, and then it's going to resynchronize and it's going to start again. Let me show you an example of where we might have a problem with leaving everything in the default settings, okay? So here, this is a college or a university campus, for example. And they've got lots of different buildings. They've got Q-SYS in all of these different buildings. And in building 5, they're actually adding a new building in, okay? And they're putting in some new Q-SYS equipment. And at the moment, everything is fine. There's a clock master somewhere. No one knows who it is, but it's all working. With building 5, they add in a new Q-SYS core. And just by chance, it just so happens that that new core has the lowest value MAC address of every core in the whole site, which is pretty unlikely, but actually did happen. And then this is what happens. It's going to trigger a grandmaster election. All of the devices are going to synchronize to it, and there's going to be an audio dropout while that happens. Now, that's annoying. Obviously, there's going to be an audio dropout for a couple of seconds everywhere, but it's probably just going to happen once, and then we can carry on with this one as the new grandmaster. Except, in this building, there's actually a less than ideal network link to everything else. So there's a fiber run and lots of switches and lots of switch hops. And it means that by the time the clock packets from here get to everywhere else, they've taken a bit too long across the network. And that means that the clock is going to work intermittently. And this is going to be a big problem, because all of these other cores are going to synchronize to this, and then the clock's going to stop working and they'll resynchronize to somebody else. And then the clock might start again and it's going to resynchronize to those. So we're going to have these constant audio dropouts, and no one really understands why, because all they did was plug in a new core. So that's why we all need to be aware of these settings and the default behavior. So this is when we might want to segregate these into different clock domains. So what we're going to do is any buildings that need to share audio between the buildings, we'll put them in the same clock domain. It doesn't matter what it is, as long as it's the same. So for example, building 1 and building 2, we will put them into the same domain, into domain 1, for example. And the other ones, we will put them into separate, different clock domains. And now everything in this building is going to have an election here. There'll be an election here, an election here, and here. But they won't interact with each other because they're in different domain numbers. And that means problem solved. So when you're installing a system, particularly if you know there's going to be lots of other PTP-v2 devices, it's probably good practice to plan in advance what you're going to have as your clock domains. Even if the only thing you do is take it out of domain 0 when you install the system, just as a precaution. And the reason I say that is there's some other third-party devices which by default do not use these numbers. By default, they use domain 0, and then priority 1 is 1, and priority 2 is 1. So that means they're basically guaranteed to become the clock master on any network you're going to put them on that's in domain 0. So just by moving your Q-SYS devices into a different clock domain, you're going to mean that you will ignore any third-party devices that are in a different domain, unless you actually want to interact with those, and then you can plan for that as well. So guys, any questions on clock domain so far? Do put those in the Q&A. James, have we got any more at this point?
Not currently, mate, no.
Okay, thanks, mate. So guys, this gets a little bit more tricky if we're using Dante and AES67. All right, and that's because obviously it's really common deployment where we're going to have Dante devices that are running in AES67 mode and interacting with Q-SYS via AES67. And that's totally fine. We do that all the time. It works really great. What you're going to see though is that the AES67 device is going to become the clock master. And this is why. So say that this is a Dante microphone running in AES67 mode, this one here in the middle. That means it's talking to other Dante devices potentially on PTP v1, which is what Dante uses. And then it's also talking to maybe Q-SYS devices on PTP v2. So it's going to become what's called a boundary clock. And it's going to become the Grand Master because that's the only way for it to synchronize with these and with these, right? If it was slaving on PTP v1 and slaving on PTP v2, then it's going to be pulled in different directions and not be able to get clock sync. So the boundary clock has to be the clock master, and you will see that if you go into your core's status block in Q-SYS Designer and look in there, it will have the MAC address of this device when that becomes the clock master rather than a Q-SYS name of a Q-SYS device. So that's fine, there's no problem Q-SYS being a slave to a system. The problem you might run into if you have a more complicated setup is that even though AES67 does support all these different domains, Dante or ordinate AES67 devices are always in domain 0. So you have to just go along with that, okay? Now, that's fine, you just put Q-SYS into domain 0 and then you synchronize to the AES67 device, right? No problem. Except, what if we have a system like this and we want to use AES67 devices that are Dante in AES67 mode in all of these buildings? Well, then they all need to be in domain 0, and then we might run into the same problem we had at the start. So that's where we might want to just use native Dante, or we might want to maybe put these in actual different networks or segregate them in some other way. But that's really a worst case scenario where we've got a really complicated system with lots of different devices in there, okay? So no problem normally dealing with AES67 and having it be the clock master, that's fine. It's worth pointing out as well at this point that Q-SYS 8.3 is now available, or I think maybe it's going to be available on Monday, but it's available basically any day now. And that has software-based Dante for the Core 110F included in that. So if you've been using Q-SYS Core 110s in AES67 mode, you can still do that. But now every Core 110 that you're going to purchase from now on actually includes 8 channels in and 8 channels out of native Dante without any additional hardware. So that means that you can configure separately, you know, Dante clocking, Q-SYS clocking, and have a bit more flexibility than you do with AES67. Okay, so we're going to move on to talking about now the next potential issue on the network, which is multicast. All right. Now, multicast is something which is really, really useful for the reasons we said earlier, for sending one bit of data to loads of different devices in a really efficient way. However, by default, if you install multicast on an unmanaged, unconfigured switch, it's going to behave like broadcast traffic. So remember, we've got unicast, which is 1-to-1. We've got broadcast, which is 1 to everything. And multicast is 1 to many. Could be everything, could be fewer. But by default, multicast is going to be 1 to everything, unless we use something called IGMP snooping. Now, IGMP snooping is a setting we can put on our switch, which is actually going to filter where the multicast goes. Means instead of it going everywhere, it's only going to go to devices that want it. Now, here's an example of where we want IGMP snooping, okay? Here we have a networked video encoder. So network video is probably one of the highest most high bandwidth uses of multicast you're going to come across. So this is spitting out 800 megabit per second in multicast onto the network. And that's quite a lot. Obviously, it's a gigabit network, so that's 80%. Now, that's going to every other device. So it's going to this network video decoder, which is good. That wants to receive that, so that's fine. And it's also going everywhere else. So it's going to these two PCs too. And those PCs don't want it, and they're still going to receive it, and they have to process it and decide that it's not for them. And in this situation, you might actually see your PC slow down because the processor is having to deal with all of this unwanted traffic, okay? But it can get even worse. So what if we have 3 encoders and they're all spitting out 800 megabit per second of multicast? Well, now all of that multicast is going to go everywhere else. So these devices are now not going to get 800 meg, they're going to get 2.4 gig. So all 3 of these added together, they're going to get 2.4 gigabit per second, and it's a 1 gigabit port. So that just means the port's basically shut down, they're not going to respond to anything else, and you essentially shut down that device by flooding it with traffic. So that's why occasionally you might find that IT teams don't like multicast or don't like lots of it. So we need to make sure we can control it properly. And that's where we're going to use IGMP snooping. So with IGMP snooping, the switch is going to ask all of the devices, what multicast streams do you want? Okay. And for example, this encoder is going to say, I want one of the streams, sorry, this decoder. And these PCs here, they don't want any of that multicast video. So they're going to say, I don't want any of that multicast video. And that's how it's going to work. The switch is then going to filter the multicast so that it only goes to the devices that want it, which is great. That's exactly how it should work, okay? Now, it's possible we come up with issues when using IGMP snooping. So firstly, when should we be using it and when should we just leave it? Well, providing it's working properly, there's no downside to using it all the time, right? But you can simplify your network configuration by not using it when you don't need to. So basically, if your multicast traffic is approaching the speed of one of the ports on your network, then you should be using it. Now remember that here we're sending 800 megabits down these ports here, and these are all gigabit ports, okay? But what if we have 100 megabit ports on the network? Well, now that port is flooded as soon as we get above 100 megabit of multicast, okay? So as a rule of thumb, I would say to use IGMP snooping anytime you have more than about 50, 60 megabit of multicast, and definitely if you have any 100 megabit devices on the network, you're going to want to do that. Now, if you have one switch, it's really straightforward. You'll just go in the switch, you turn on IGMP. There'll probably be some specific settings for that manufacturer, but essentially it's quite straightforward. Where we do see issues occurring sometimes is when you have multiple switches, okay? And this is where we're going to want to change it slightly. So with IGMP, you have the querier, and the querier is the thing that's actually asking questions to all the devices. So the querier is saying, do you want multicast? Do you want this multicast? Do you want that multicast? And the devices say, I do, or no, I don't. Now, we should only ever have one querier on a network, okay? So for example, here, I've got 4 switches. What I'm gonna do is enable IGMP snooping on all of them, but I will turn the querier off on all but 1. And that means it's going to work better. If you have multiple queriers, you will probably see problems with multicast. Either it's not filtering properly or it's filtering too much. So just make sure you've only got one querier on the network. James, any questions on multicast or clocking or any of those things?
We've got some questions, yeah. So are there any network scanning utilities to see what devices might be interfering or causing conflicts?
There are, and actually I'm going to come on to that very shortly, so I'll come back to that one.
Okay, perfect. How is the PTP version translated in software Dante? Are you restricted to domain 0 when using it?
Yeah, so software-based Dante essentially works just like normal Dante. which means it's PTP-v1 and it's always domain 0. Now we can still change the QLAN domain or PTP-v2 the same way we always could, but Dante is going to remain in domain 0 because that's how Dante works. So yeah, if you go in 8.3 into design properties, it says PTP-v2 domain, not PTP-v1, which is what we're using for Dante.
Cool. Is the domain a property of each connected device, or are the additional settings required in the network switch when changing domains? How do different domains then communicate with each other? Via DDM for Dante and AX67?
Okay, so it's not different networking domains. It's essentially just it's just a number that the clock has attached to it. So when the clock goes out, it says, I'm in domain 1, I'm in domain 0. And before another device interacts with that clock and synchronizes with it in some way, it just checks to see if that number is the same as the number it is using. So if they're both in domain 0, then they will work out who should be the grandmaster. If one's in domain 0 and one's in domain 1, then they just totally ignore each other. So it's not anything you have to do on the network or with Domain Manager. It's something that you just do on the devices, and essentially devices with the same domain interact with clocking and devices with different domains do not interact.
Thank you.
Thank you.
That's it
yeah,
now.
Good questions, guys. Keep them coming. Okay, now just another word on bandwidth while we're on the topic. You guys will know that Q-SYS audio probably doesn't use that much bandwidth most of the time. However, the biggest QLAN systems, so if you have a Core 5200 and you've maxed it out, so 512 inputs, 512 outputs, that is quite a lot. That's about 850 megabit per second. So you definitely need to make sure you've allowed for that on the network. But most of the time, audio is not going to be super high bandwidth because it just needs loads and loads of channels, okay? Just so you know, one stream with 16 channels of QLAN, it's about 26, 30 megabit per second. So you can just have that and remember that, and that's how you can work out the bandwidth. Or if you're using Q-SYS Designer, you can go into check design and you will see the bandwidth used for audio coming in and out of the core, all right? Now, redundant networks, they use LAN A and LAN B at the same time. So those two networks will have the same audio traffic there, all right? Now, just a couple of other little notes about QLAN networking. We do have this thing here called Core Manager. If you've used Q-SYS, you will be familiar with this. This is where we can set all the core's settings. Now, for security, you might want to turn off some protocols, or maybe the end customer will want you to only use the protocols necessary on their corporate network. And in this situation, what I'm talking about is, let's say we have our Q-SYS core with LAN A on a AV network that you can do whatever you want with, and LAN B is going to the corporate network just for VoIP, for example. So there you might want to turn off on LAN B, Q-SYS discovery, Q-SYS clocking, a few other things. And that's just going to be helpful for the IT team on that site, because they might say, I thought you were just doing VoIP. What's all this QDP stuff coming onto our network? You can just turn that off here in Network Services in Core Manager, okay? Just be careful, don't turn everything off, because then it's going to be very difficult to log in and make changes, okay? So turn off stuff that you don't need on a certain network port. Now we have a few other general networking things that we ask people to look out for, okay? These are just sort of network best practices, all right? And the first one is having dual default gateways. So, like I said, on a Q-SYS core, you can have LAN A and LAN B, or you could have LAN A, LAN B, and an aux LAN as well. Now, if you have a default gateway on both of those, it can cause some unpredictable things to happen, okay? This is just like when you have your PC and you connect your PC to a network with wired, and then you also maybe connect to a wireless network, and then you find that your internet isn't working consistently. And that's because you probably have dual default gateways. Now, what do we need a gateway for? Let's just remind ourselves what a gateway is. So a gateway is usually a router that is actually going to take traffic from one network and put it into another, okay? So if we don't need to leave our subnet, and often in the AV network, we probably don't. If we don't need to leave our subnet, we don't need to put in a gateway. And if we don't have a gateway, then we don't need to put in the gateway as well. So quite often we see a gateway entered in network settings, and there's actually no gateway on the network. And then they have another gateway on LAN B. Now, if you have two, then sometimes the operating system will try both because they're both default gateways, and this can cause issues. So only use a gateway if you need one. If you really do need one on both networks on a core, then it's better to use a default gateway for one connection and static routes for another. And we're not going to go into static routes here, but you can have a look at that on the help file. It's essentially going to say, rather than a big default gateway, it's going to say, for this specific subnet, go to this gateway. You know, so you can be more controlled about it. Now, also, multiple networks that all have the same network range. So if you've got LAN A, LAN B, those should be different ranges. Maybe one of them is 192.168.0. something, and the other one is 192.168.1. something. That would be okay. But if you have two networks that both have the same network range, that's going to cause a similar problem. The operating system is going to treat them sort of similarly because they have the same range, even though it's separate hardware. And also, don't connect LAN A and LAN B to the same switch in the same network as well. It can cause the same problem. Don't send 802.1q tag packets to a core. These are packets to put devices into a VLAN or to do VLAN trunking. Normally, we don't see this happening. This occasionally will happen because some VoIP phones can be put into a VLAN in this way. Basically, you should treat your ports that are connected to a core as just standard networking ports where the port is in a VLAN itself rather than you tagging the devices. And also jumbo frames. Now, jumbo frames are Ethernet frames that are bigger, they have more bytes inside them, and they take longer to process going through a interface on a switch. So CCTV sometimes has this, other things sometimes have this. It's going to mean that maybe your quality of service policies aren't going to be as effective because sometimes a frame is going to come along and just block up that whole interface for a long time. So we don't say that jumbo frames will totally break your network, but we have seen issues where lots of jumbo frames do cause issues with time-sensitive protocols like clocking and audio. Now, one other tip for you guys. Someone was asking about network monitoring tools. So the first one you should all have is Wireshark, okay? Wireshark is really great. Wireshark is going to let you plug into a network and it's just going to show you every single packet that's coming in and out of your PC. So this is going to show you, for example, IGMP queries. You could filter by IGMP and see how many different queries you get. You should only have one. Or you can use something like PTP TrackHound. Now, PTP TrackHound works very similarly to Wireshark. It captures the packets coming in to the network, but it only cares about PTP clock packets. So that's actually going to show you then all of the clock packets that are on the network, and then it's going to show you what that means. It's going to show you all of the grandmasters and all of their slaves. And once that's been running for a little while, you should find that it's stationary and it's not changing. But if it keeps changing all the time, you can see why. You can see what clock packets are coming in that's causing it to change. So that's very handy as well. Now in Q-SYS Designer, we have a thing called verbose mode, which is where we can set more information to appear on our cores and on our audio I/O devices. So if you select, for example, this IO8 Flex status block, and you come down here and you say verbose yes, then it's going to give you this little window here. And here, I don't know if you guys can read that, but it says connected, DSCP, and accepted, accept count, it says. Now, connected equals 1. That means, yes, it's connected. So the audio stream is connected. It says DSCP equals 34. So remember, with the default quality of service preset, audio is 34. So that's fine. That's what we'd expect. Sometimes you will see something weird like DSCP equals some weird number or DSCP equals 0. We once had DSCP equals 0. We went to the IT team and they said, oh yeah, we just strip off all of the DSCP tags when it comes into the network. Don't know why, but that wasn't very helpful. So that meant all of the quality of service didn't work. So we just asked them, can you not do that? And then everything worked. So this is very useful for troubleshooting like that. And then also sometimes in the status block, you're going to see packet missing, something like that. This here is going to show you that in more detail. So here it says accept count, and that is a big number that should be going up by 3,000 packets per second. And that is because Q-SYS sends 3,000 audio packets per second per network audio stream. Okay. Now, if that is going up by less than 3,000 a second, you're going to see some other entries. You're going to see packet missing, packets lost, packets that are too late, and then you can see basically what packets are being late or missing. And then you can take that to the IT team and say, look, we're getting hundreds of late packets. Can you turn quality of service on, please? Also, you have, for example, if you have like one missing packet, then you see that there, it will say missing 1. And then it might just be some freak accident and you don't need to worry about it. Whereas if it's like thousands, then obviously you'll hear it and it's going to be a big problem. James, any other questions?
Yeah, we've got another question. Are there any recommendations for using jumbo frames? For example, IP video distribution where Dante is being used to interface the audio from the encoders with Q-SYS.
Let me just have a look at that one again. So were they saying they're using jumbo frames for video distribution and Dante?
Yeah, is there a recommendation for using jumbo frames? So, and they just put an example in there saying.
The recommendation is don't. But if you have to, you just want to avoid those jumbo frames being on the same network interfaces as Q-SYS clocking, Dante clocking. Now, just because you have them, it doesn't mean it's not going to work. Like, it's just that if you have loads of jumbo frames going down the same interface as like Q-SYS audio, then it might cause an issue. So we don't really have any specific recommendations other than telling you that the problem exists and that you need to be aware of it. And you could plan around it, I guess, if you could segregate those networks in some way. It sounds like you've got network video where that is going to send Dante out of it. So yeah, I don't know. I don't have any specific recommendations for that, but I would definitely say do some testing with it. And if it's working okay, then okay, right? It's not, we're not saying it's definitely going to cause an issue, but it could do, and you should be aware of it. I know that's not super helpful.
Considering AES67 has the same QLAN DSCP, when we use ordinate presets in the design configuration, do we need to change the other AES67 devices DSCP? Is it possible to do that?
It's a great question. So I didn't mention this. So yeah, AES67 in the standard has the same DSCP as Q-SYS. However, in a shocking twist, ordinate don't use it. So when ordinate devices are in AES67 mode, you see here, it's going to then use ordinate DSCP. So any Dante devices on the network, whether they're in Dante mode or AES67 mode, they have the same DSCP tags, which is 56 and 46. I think, yeah, here we go. So with QLAN, you can use that with QLAN network or QLAN and a native AES67 device. Now, it's probably fair to say that there's more Dante AES67 devices than native ones. But you're right, the standard specifies this, but Dante used this. So use this if you're using Dante or Dante AES67.
That's it for current questions.
Cool. Good questions, guys. All right, well, in that case, we've only got a couple of other little things to touch on, which are just some other useful things to know about that are going to help you solve problems on your network. The first one is this URL. Can everyone screenshot that or write it down? I don't think this is written in the help file anywhere. I could be wrong. It's sort of a secret URL that is going to let you run Wireshark packet captures on the Q-SYS device rather than on your PC, which is really, really useful, because to capture what's coming in and out of a Q-SYS core with your laptop, you would normally have to do like a port mirror on the switch to mirror the Q-SYS port to your PC or something else. You can just tell the core to run Wireshark internally, and then you can download the packet capture and then view it. Now, it's really helpful for diagnosing clocking issues, VoIP issues, all sorts of other things, discovery problems. Now, you go to that URL. I'm going to give you 5 seconds to screenshot it. Okay. And then it's going to take you to this beautiful web page. And on this web page, you can choose what network port you want to do the capture from. So LAN A, LAN B, aux LAN. You can filter here. You can filter and say, I just want to see clock packets or something like that. I would normally filter in Wireshark, but you can do it here as well. And then you can do a few other things. Essentially, once you've set it up, you can hit a start button, then you can hit the stop button, and then you can hit download, and you're going to get the PCAP file, which you can then view in Wireshark, which is super useful. Sometimes QSC support are going to ask you to do this. So this is what we're talking about when we ask you to do a packet capture on the core. And one other URL to be aware of is the core's IP address /sip.txt. This is going to help you troubleshoot any VoIP problems specifically. So if you go into Core Manager and you enable logging in the softphone section, there's a little tick box for enable logging. Then when you go to this URL, you're going to see a big old load of text, which is the whole conversation that the core is having between the core and the VoIP server. So for example, if you can't register your soft phones, or when you call, the call just drops, and you want to get all the detail about why that is, this is what you want to do, okay? And that's going to take you to something that looks like this. And it's going to look different for every system. You don't need to understand all of this. If you do, then that's really great. But what it's really useful is for saving and sending to the VoIP administrator and then saying, this is what's actually happening. Can you have a look at that? But you can see here we've got send up the top there. So we're sending a message, and that's the message we're sending to the server, and then we're receiving from the server. So even that on its own shows us that we have connection to the server, even though it's not working, and that might explain why over here. So let's just summarize a few key points that we've touched on as we come to the end of the training. Remember, guys, that we need quality of service for time-sensitive protocols. So let me move out of the way, and then you guys can just have another look at that table. So we have discovery, which is multicast but not time-sensitive, and then clock is multicast and time-sensitive. Audio is just time-sensitive, and you're going to need to make sure multicast works, and you're going to need to make sure that the QoS works as well. Doesn't really matter what the DSCP tags are, essentially, as long as clock is highest priority, audio is second highest, and video is third highest. Remember, with IGMP snooping, we just want one querier. We don't want loads of queriers, and we want filtering or snooping enabled on all of them. And remember to go to qsyshelp.qsc.com and click on networking, where there is a really big topic that you can look through for all the detail that we've talked about on this. It's also very useful if you are an integrator and you need to work with a client IT network. Send them this well in advance so that they know and they understand what's expected of their network when you show up with all the equipment. So guys, that's it. That's been the networking training. And now we'll just take any other questions we have. James, are there any last questions there?
There aren't any last questions, but we have just a question earlier around the other webinars that we deliver, and just people want some information around those.
Yeah, sure. Guys, the best place to see those is if you go to blogs.qsc.com. James, could you pop that in the chat to everyone? So
was it
blogs.qsc.com. And that is where we have our team are just putting all the webinars in there as they come out, okay? Also keep an eye on QSC LinkedIn, QSC Facebook. We'll be posting stuff on there as well. So you should have enough notice once we've posted something to get registered and get signed up.
Perfect, that's in the chat now.
Thank you very much. Okay, great. Now, guys, one last word from me. You've probably noticed this above me here, Q-SYS Level 2 training. So this is an extract from the in-class training we do, particularly here in QSC UK, where I'm in the training room right now. As you can imagine, it's not that busy right now with all of the social distancing that's going on, but Level 2 will be resuming later in the year. So do keep an eye, if you're in the UK, on the QSC training site, where we will be listing more training events there, including Q-SYS Level 2. So my name's James Martin. Thank you very much for attending. I hope it was all very useful, and maybe I'll see you again on another webinar shortly. Cool. Thanks very much, guys.